All right, let's dive in. This is the deep dive where we take the sources you've given us and really try to cut straight to the most important knowledge and maybe surprising insights. We want to make complex topics, well, understandable and hopefully interesting too. Today, we're plunging into a field that's absolutely critical for healthcare, but, often operates behind the scenes pathology. Specifically, we're exploring how artificial intelligence is transforming it, dramatically improving diagnosis speed and accuracy right there in the lab. So pathology is, at its core, the study of disease, right? Often involving examining tissue samples under a microscope. When you think about that work, wow, it just seems incredibly detailed and demanding.
Oh, it absolutely is, yeah. If you imagine a seasoned pathologist, like the sources mentioned, their job is, well, looking at these tiny slices of tissue and making diagnoses that, profoundly impact patient care. It's a profession with just immense responsibility. Think long hours, constant pressure for accuracy, hour after hour just focusing intensely on slides. Your eyes can get tired, right? Subtle details might get missed, maybe a crucial mitotic figure, something that shows how aggressive a tumor is. The sources really highlight this reality. It's demanding, it relies on expert human judgment, but that judgment can be subjective. It's susceptible to fatigue, and it's definitely challenged by ever-increasing workloads. And that's precisely the critical problem AI is stepping in to, well, help solve.
Okay, so the core challenge AI addresses is augmenting human capacity. In this high-pressure, super detail-oriented environment, how does AI actually achieve that? What does it do?
Well, what's truly fascinating, I think, is that AI isn't coming in to replace the pathologist. That's key. It's specifically designed to act as a powerful extension of their abilities. Think of it like this. The pathologist has their expertise, their experience, and AI becomes this tireless objective assistant. It can pre-screen just vast amounts of data, flag subtle anomalies the human eye might miss, precisely quantify features, and integrate different pieces of information for a truly objective assessment. One source uses this great analogy of turning a microscope into a high-powered telescope.
A telescope, okay.
Yeah, revealing insights you just couldn't see before. It's positioned as a vigilant guardian, a powerful helper. This isn't about automation taking over. It's really about empowerment.
A high-powered telescope for looking at tiny cells. I like that. Okay, let's get specific then. How is AI being applied in labs right now to speed up diagnoses and make them more accurate?
Okay, well, one significant area is in digital pathology. This involves scanning those traditional glass slides to create high-resolution digital images.
So instead of staring down a microscope eyepiece, they're actually looking at a screen.
Exactly, yeah. And that simple shift opens the door wide open for AI. These AI systems, they're trained on massive data sets, like huge numbers of annotated slides, cancerous, non-cancerous, and they can then scan these digital images themselves. They use these complex models, often things like convolutional neural networks, which basically learn to recognize intricate patterns and textures that indicate disease right down at the microscopic level.
Wow.
It's sort of like having an AI-powered magnifying glass that quickly highlights suspicious areas on the digital slide. It immediately directs the pathologist's attention to what's most critical. For instance, in a lung cancer screening program, AI can pre-filter cases. It flags only those with potential abnormalities, which drastically reduces the volume a pathologist has to review manually.
So it's not just finding issues faster, it's finding the right issues faster, letting the pathologist be more, efficient with their valuable time.
Precisely. Yeah, exactly. And this translates directly to faster turnaround times for patient reports, which is huge. And of course, a much more efficient use of pathologist time and lab resources. And beyond just that initial screening, AI is tackling tasks that are, frankly, manually difficult and very time-consuming, like automated mitosis counting.
Mitosis counting, okay. What's that exactly and why is it important?
Right. So mitosis is cell division, and the rate of mitosis, how fast cells are dividing, is a really crucial indicator of how fast a tumor is growing and, how aggressive it might be. Pathologists have to manually identify and count these dividing cells under the microscope to grade tumors.
Okay, I can see how that would be tedious.
Oh, incredibly tedious.
Yeah.
And subjective, too. And it's prone to variability, depending on who's counting or even how tired they are that day.
Right. And the AI automates this. How does it make it more accurate or objective?
Yes, exactly. AI algorithms are trained specifically to identify these mitotic figures. And because the AI system follows a consistent algorithm every single time, it provides a highly objective and reproducible count. Consistency. Yeah, that eliminates the variability you get with manual counting between different pathologists, or even the same pathologists on different days. The sources highlight a massive time saving here. A task that could take hours manually might be done in minutes by the AI.
Hours to minutes. That's significant.
It really is. And it's not just about speed. It provides a more consistent, reliable metric for tumor grading, which improves diagnostic accuracy overall.
Wow. Okay. Hours to minutes and increased objectivity. That's a huge impact. What about ensuring that cancerous tissue has been completely removed during surgery? That seems like another really critical step.
Absolutely vital, yeah. This is where tumor margin assessment assistance comes in. Making sure the margins, the edges of the tissue that was removed are completely clear of cancer cells is, well, vital to prevent the cancer from growing back. And checking these margins can be quite challenging, especially with, say, irregularly shaped tumors.
Right, those fuzzy edges. And AI helps clarify those.
Exactly. The AI algorithms can analyze the digital slide of the removed tissue and specifically highlight areas near the margin that look suspicious. Or maybe areas where it's just unclear if cancer cells are present. It provides a sort of objective second look, you could say.
Like a second opinion built in.
Kind of, yeah. It draws attention to those tricky spots. And this helps the pathologist make a more confident decision about whether the margins are truly clear, or if, perhaps, further surgery might be needed. This directly improves patient outcomes and potentially avoids the need for repeat procedures.
Okay, so it helps them make the best possible call on a really critical step in treatment. What else can AI analyze? Is there more?
Oh, yeah. One final, quite complex area is immune cell infiltration analysis. Basically, the types and numbers of immune cells present within and around a tumor can tell you a lot. It can indicate how the patient's own body is responding to the cancer and even predict how they might respond to certain treatments, particularly immunotherapies.
That sounds incredibly complex to analyze manually, just trying to picture counting all those different cells.
It is. It really is. Identifying and quantifying different types of immune cells, figuring out their spatial relationship to the tumor cells. It's very difficult and time-consuming by hand. AI can automate this analysis. It provides a detailed quantitative map and count of the immune cell landscape within the tumor environment.
A map of the immune cells.
Yeah, pretty much. And this precise data helps pathologists predict treatment response, which in turn guides oncologists towards the most effective therapies for that specific patient.
These applications, they really paint a clear picture of AI as this powerful assistant across different stages of pathology. So how are these systems actually being built and, put into practice? Especially considering different environments like India, which the sources mentioned.
Right. Building these systems, well, it typically involves training AI models on vast collections of digital slides, huge amounts of data. They often use techniques like transfer learning, where a model trained on one task is adapted for another. Tools like TensorFlow or PyTorch, often open source, are frequently used.
Okay, so the tech side, what about getting it into the lab?
Yeah, implementation requires seamless integration into the existing lab workflow. That's crucial. The software needs to be easy for pathologists to actually use day to day. In places like India, the strategies discussed include starting with focused pilot projects in specific hospitals, collaborating really closely with pathology labs to gather and meticulously annotate the necessary data for training. That annotation step is critical. And leveraging open source platforms to make the technology more accessible is also a big factor.
And training the humans involved?
Oh, absolutely essential. Training pathologists is key. They need to understand how to use the tools effectively and how to interpret the AI's output correctly. Plus, robust data privacy and security measures are paramount, obviously, given the sensitive nature of the information. And crucially, especially in environments with varied infrastructure, the systems need to be designed to handle potential limitations, like maybe lower bandwidth for transferring those massive digital slide files.
Right. Practical considerations. It sounds like building the tech is only part of the challenge. Integrating it effectively requires a really thoughtful strategy. And the results seem promising. You mentioned improved detection, reduced errors, faster processes earlier.
Definitely. The benefits are tangible and significant. The sources point to concrete outcomes like a reported 40% reduction in the time it takes to generate a pathology report.
40%?
Yeah. Think about what that means, right? Faster answers for anxious patients, quicker decisions on treatment plans. It's huge. They also highlight a reduction in diagnostic errors because the AI acts as a kind of safety net. It highlights areas or components the pathologist might otherwise have overlooked. So it really does improve overall accuracy and efficiency, which leads to reduced costs in the healthcare system and, most importantly, just better health outcomes for patients. It's not just about automating tasks. It's fundamentally about empowering pathologists with better tools.
So connecting all these threads then, the core message really seems to be that AI isn't replacing the, irreplaceable human expertise of a pathologist, but rather augmenting it, creating a powerful partnership.
Exactly. Yes, that distinction is absolutely critical, and it's borne out by all the sources we looked at. AI is a tool, a powerful one, no doubt, but it's there to enhance the pathologist's abilities, not substitute for them. Human oversight remains absolutely essential. Always. Healthcare professionals, the pathologist, they retain the final diagnostic responsibility. That doesn't change. AI is the assistant, maybe the co-pilot, helping them navigate complex cases and manage that workload more effectively. It allows them to focus their unique human skills, critical thinking, correlating with clinical data, handling the truly nuanced cases exactly where they are needed most.
That human-AI partnership really feels like the key takeaway here. Thank you for guiding us through the fascinating way AI is transforming pathology. It's really remarkable to think this technology is quietly accelerating diagnoses and improving accuracy, ultimately impacting patient lives in such a direct way.
My pleasure. It's certainly an exciting field.
So what does all this mean for you listening right now? Well, we've seen how AI is fundamentally changing pathology. Not by replacing expert pathologists, remember, but by giving them these extraordinary new tools, from quickly scanning vast digital slides for anomalies to precisely quantifying markers like those mitotic figures we talked about, to helping ensure surgical margins are clear. AI is proving to be an invaluable partner in the lab. This application of intelligent technology isn't just improving efficiency, though that's important, it's directly contributing to better health outcomes for you. It's ensuring conditions are diagnosed faster and more accurately, paving the way for more timely and effective treatment. So, maybe something to think about. Consider how this blend of deep human expertise and cutting-edge AI assistance might be quietly shaping the future of healthcare diagnostics for everyone. This has been a deep dive into the world of AI and pathology.